Okay, so here is our first example. So example number 1. So using this fundamental theorem of algebra and linear factorization, I want us to do this. I want us to figure out what is a third degree polynomial with zeros at 3 and negative I. So that's my question. Okay, so a couple things in here we know is that it's a third degree, which means then my highest degree should be n is equal to 3. I should have 3 zeros, and I should have 3 factors. Those are our 3 things. So I do have 2 zeros right now, 3 and negative I, but then if I remember my previous note earlier, I had said complex zeros and irrational zeros come in pairs. Okay, so that is what that says, pairs. And so, which means that my 3 zeros are not just 3 and negative I, but I also have a positive I. So there's 1, 2, 3. So there's my 3 zeros. So what do I want to do? So I need to first write an equation. So what I like to begin with is I like to know where my x used to be. So I solved an equation and I got x was equal to 3. I solved another equation and I got x was equal to negative I. And finally a third equation and I got x was equal to I. So what was that equation? That first one was probably x minus 3 equal to 0. This was probably x plus I equal to 0. And this was probably x minus I equal to 0. So all, if you think about this, all factors. So all binomials. And so we want to put it into an equation. F of x is equal to x minus 3, x plus I, and x minus I. If I told you to write it as a linear factorization, this is a linear factorization. All of the terms are linear, x, 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 and it is all in factored form. But that's not what I'm asking. I want a third degree polynomial. Technically, this is also a third degree polynomial. Let's be more specific. Let's put it in general form. So this is in factored form. So let's say put in general form, which means multiply your factors. Okay. So what I like to do is I like to multiply my conjugates together right away, so I know that things cancel out. And sometimes I like to use the area model that we learned in integrated 1, 2, and 3. So there we go. So this will give you x squared. This gives you ix, negative I, and negative I squared, which turns out to be negative times a negative 1, which turns out to be a positive 1. So if I collect my like terms, this will be x minus 3, and this will become x squared plus 1. Again, notice it's no longer in linear factorization, right? This is still linear, but now this is a quadratic. Don't drop your equal sign. I'm going to leave f of x off until the very end. Again, I'm going to factor this guy, or multiply this guy out. And again, I like to use the area model. And x squared plus 1 up top, x minus 3 on the side, x cubed, x, negative 3x squared minus 3. So here is our polynomial, x cubed minus 3x squared plus x minus 3. That's as far as you need to go. Again, notice it's a third degree. Third degree. What we could do is we could check to see if this polynomial actually works by plugging in our number. Right? If I plug in a 3, I can figure out what 3 cubed is. And then subtract that from 3 times 3 squared, add 3, and then minus 3. And the answer should be 0. Right? Same thing if I plug in an I or a negative I. All right. So let's try a harder one. So let's call that example 2. So I want a 4th degree polynomial. And this time I have the zeros are going to be a 1 plus root 3i and 4i. If you want to pause it at any point, feel free. But we're just going to dive right into this. So 4th degree, so I know my n is equal to 4. Again, we're going to write it in general form. So let's do general. My zeros are 1 plus root 3i, so that means I also have a 1 minus root 3i. If I have a 4i, I also have a negative 4i. Notice for conjugates, you're never changing the 1 in front. You're only changing what makes it become a radical, or what makes it become an imaginary number, right? So that's your plus or minus part. Okay, so the first thing I like to do again is x is equal to 1 plus root 3i, x is equal to 1 minus root 3i, x is equal to 4i, x is equal to negative 4i. Move everything over, x minus 1 minus root 3i, that was equal to 0. This will be x minus 1 plus root 3i, x minus 4i, x plus 4i. Again, all of these are factors. So my first one, second one, third one, and x first. And finally, the 4th factor. Okay, again, please note that this is now in linear factorization. Okay, if I had said that's as far as we needed to go, right? But I did earlier say let's put it in general form. So we would be done. But we're not done. So again, I like to multiply my conjugates together so that way my radicals can go away and my i's can go away. So I'm going to multiply those guys together and these guys together. So again, I'm going to show that off on the side with my area model. So this time it is now a 3 by 3. So I have an x minus 1 minus root 3i, x minus 1 plus root 3i. Let's use green. So I got x squared minus x minus root 3ix. Kind of looks like you're going to take the radical of 6. Negative x, positive 1, positive root 3i. This becomes a positive root 3ix, a negative root 3i, and this becomes a negative root 9i squared, which is negative 3 times negative 1, which turns into a positive 3. So remember, radical 9 gives you that 3. We still have that negative. I squared is negative 1. Negative times a negative turns positive. So great news. Right? Notice that this guy and this guy cancel each other out, and that guy cancel each other out. So first set of terms I have is x squared minus 2x, and then add the 1 and the 3, and I get 4. Okay, now we're going to do the same exact thing over here. This time I'm not going to show the area model. I'm just going to write x times x will give you x squared. This will give you positive 4ix, negative 4ix. This will turn out to be a negative 16i squared, which will turn out to be a positive 16. Okay, and we have to multiply those together. So let's do this again one more time, and I'm going to put that right here. All right, so this time it's a 2 by 3. So figure out where you want the 2. X squared positive 16, and get our green. So let's begin. We are going to get x to the power of 4, and then minus 2x cubed positive 4x squared. And then here I will have a positive 16x, and then a negative 32x, and then a positive 64. Again, notice no i's or radicals, so that's awesome. And then collect our like terms as we write our equation. Highest degree, power of 4, which is what we wanted. Okay, cubed would be next, so minus 2x cubed. Add the 16 and the 4, so 20x squared minus 32, and then plus 64. Bam. And that is our answer. Okay. So what else can we do with these problems? All right, turn into part 3 to try out some more factoring and understanding that.